All right, lesson 8.3 is multiplying and dividing rational expressions. Now, first of all, some of these rational expressions, there are basically three rules that you need to apply, and we're going to take these in stages. The first couple that we do are only going to work with rules 1 and rule 2, and then after we get those, then we're going to add in rule 3. Before we get started, and basically the rules are, let me start there. Rule 1 is you may only cancel variables. You may only cancel diagonally or on top, but never across. So in other words, anything on the top can be canceled with anything on the bottom. Okay. If A is positive, or I'm sorry, if A includes a plus or a minus sign, okay, and this is the second part of this, then you're going to include, or include in the problem. Let me start this over. If the polynomial, the top or the bottom of the expression, includes a plus or minus sign, then you're actually going to have to cancel the entire polynomial, the plus or the minus. Never cancel just the variable or just the constant. Okay, in most cases you're going to have to factor it, and you're going to get it down to an x plus or an x minus something, and then you'll be able to cancel it. So let's go and take a look at a couple of examples. If you remember some of the minor rules that we did, let's review some of those before we actually tackle this problem. Whenever we multiplied x squared times x to the third gives us x to the fifth. Okay. Remember when we had negative exponents, it moves it, it changes its position. Okay. So if it's in the bottom, it moves it to the top. If it's in the top, it moves it to the bottom. And then the last one is, the one that's the most important, is when you subtract. Remember, when you're dividing, you actually subtract the expressions. And I usually think about it wherever, once you've taken care of your negative exponents, wherever you have the most variables, that's where it needs to go. So since I have x to the fifth on the bottom, that's why x squared ends up on the bottom. Okay. So let's take a look at this example. Whenever you're multiplying two expressions, and these would be monomials, the very first thing that you need to take care of, okay, and again, this is for monomials, you'll notice there's no plus or minus signs inside of there. Then just look at your constants, the 5, the 2, the 6, and the 10, and you can simplify those, okay? Now remember, I can do anything on top with anything on the bottom. Okay, so I know 5 and 10, so I can divide both of those by 5. So 5 divided by 5 goes away. 10 divided by 5 causes me to get 2. And 2 and 6. 2 divided by 2 cancels. 6 divided by 2 is 3. Okay? And then I would always look for negative exponents. Do you have any negative exponents that you can actually move the problem up and down? And we don't have any. So what we're actually going to do is let's go ahead and collect all of our variables. So x squared times x to the third would give us x to the fifth. Don't forget about your constant 3. Y times y squared would give us y to the third, because anytime there's not an exponent, there's an invisible 1. Okay. On the bottom, again, we always put our coefficients first, so we're going to have 2. There's only one variable of that, or one factor of x, at y to the third times y would give us y to the fourth. So when we collect all the variables on the bottom, we're going to add them. The next step would then, we need to make sure and simplify. Well, the 3 over 2 doesn't simplify any further, so we're going to leave it 3 over 2. X to the fifth over x, remember, we can simplify that. All we have to do is subtract them. And 5 minus, remember there's an invisible 1 here, would give us 4. And x to the fourth would stay on top because we have more variables, or more factors of x on the top. And on the bottom, we would subtract those, get just a y, and we would get just a y on the bottom because we have more factors on the bottom. Okay? All right, so this should be a review of what we did these back in Unit 5, back first semester. So go ahead and do the next one as a you try. So go ahead and pause the video and see if we can do this one on our own. Okay. All right, so the very first thing you need to do is see if we can go ahead and simplify. Now, I'm probably going to do this in a little manner. Some of you may have seen the 6 and the 18, perfectly fine. But I also could take a look and say, hey, wait a minute, I could divide this one by 2, so I can divide that one by 2. I can go divide these by 2, so this ends up being 5, and if I divide this one by 2, 9. And I can still go diagonally with the 3 and the 9. So your end result's going to be the same. You're going to get a 3 on the bottom, okay? I don't have any negative exponents, So the only coefficient I have on top is just the 5. And then I have x squared times x to the third gives me x to the 5th, y to the 7th, and on the bottom I have a 3, x squared, y to the 4th. Okay? And then I can go ahead and simplify those by doing a 5, a 3. I can subtract my variables, so I get x to the third, and then I have a y to the third when I subtract those. So I end up with a y to the third, okay? Because I have more factors on the top. All right, before we move on to the second part of this, which is actually simplifying these when we actually have radicals, there's a couple of factoring that I wanted to review with you. Whenever you have an x squared minus 9, the first one's a perfect square and the last one's a perfect square. Remember, this is going to be x plus 3, x minus 3. Okay? So just take the square root of both. One's plus, one's a minus. Whenever we're faced, the other problem is whenever we're faced with a binomial and there's an x squared in there, typically they can't be factored. And you got to say, okay, what do these both have in common? Well, we know they have an x in common. 6 and a 1, those that don't have anything in common, so I can factor out x. So a lot of times this is called factoring out a greatest common factor. So this would be just 6. X squared divided by x would give me x. X divided by x would then give me a 1. Okay? So let's go ahead and take a look at the very first example. I'm sorry, this would be example number 3. And as you'll notice, one of the common mistakes that people are going to make is they're going to want to do this. And then they're going to see the 4s, and I'm done. That is incorrect. I want to stress to you that is incorrect. Okay? We cannot, whenever the variables on top and the variables on the bottom are the same, we can't just simplify them when there is a plus or a minus sign. And if you'll notice, there's a plus and a minus sign on this. So in this case, the first thing that we have to do is we have to factor all polynomials. And once we've factored them, as far as we can factor them, then we can look at doing some canceling. So when we factor a trinomial on top, we have a negative 12. So if you remember, negative 3 times 4 gives me 12. Negative 1 times 12. Negative 2 times 6. And this one right here will give me a 4, but all I have to do then is change my signs. And that'll give me a negative 4. So this factors into x plus 2, x minus 6. Okay? And on the bottom, remember that one that we just discussed, it's an x squared minus 4. So it's a difference of squares. So it's going to be an x plus 2, and it's an x minus 2. Okay? And then now that we've got it factored, as long as you factor, the plus basically connects the variable and the number. So in other words, the plus in this one is going to connect the x and the 2. So that one I actually can go ahead and simplify by just canceling the x plus 2 and the x plus 2. And the only thing I'm left with then is x minus 6 over x minus 2. Okay? So go ahead and try the next one. It's x squared plus x minus 2 all over x squared minus 1. If you've printed the note sheet, then I would suggest go ahead and try this, using this as an example before moving on. Okay, so let's go ahead and do the last example, example number 4. And as you notice, we've got plus or minus signs, so we just can't simply cancel our variables. So let's find, so we're going to have to factor everything. So I find out that negative 2 times 1 will give me a negative 2. But when I add this one, I get a negative 1. So all I have to do is switch my sign. So let's make it a positive 2 and a negative 1. So on top, I get x plus 2, x minus 1. And on the bottom, perfect square. And this one's a perfect square. So remember, it's x plus 1, x minus 1. Okay? And whatever's inside the parentheses, if it is the same, then remember, I can just cancel it off. So x minus 1 would cancel. And I get x plus 2 over x plus 1. Okay. as your final answer. Okay. Well, this concludes video 1. There is a second video. If you'd like, maybe a good idea to go ahead and maybe do a couple of practice problems that are very similar to this, and then go ahead and take a look at video 2 before moving on. Thanks.